It should be. Let me see. Maybe I didn't unlock it yet. For those of you who want to take notes on the slideshow. Hold, please. Oh, I neglected to unlock it. I apologize. Okay, there's that. How many of you are taking notes on the slideshow? Are you using the PDF or are you using the PowerPoint? PDF. Okay, so just so, I mean, if you're not using the PowerPoint, I won't post the PowerPoint, I'll just post the PDF, unless you feel like you need it. All right, so we are going to talk about infinite limits. Ooh. Both today and Thursday are limits involving infinity. The difference is, one of them, the answers will involve infinity. That's today. The other one will take a limit as x approaches infinity. Okay, so today we're doing mainly vertical asymptotes. This is easy peasy. We'll go through that quickly. Because you can all find a vertical asymptote, I assume, right? We'll talk a little bit more about the left and the right business. We're going to have that burned into your skull. We're going to talk about where vertical asymptotes come from, or I should say review where vertical asymptotes come from, because we've done that quite a bit. And we're going to make sure that you don't dive into things thinking it's infinity when it's just a simple plug and chug. Every single limit problem you do should be done as a plug and chug first, because it might turn out to be very simple, and you can make it a lot more complex by not realizing that it's plug and chug. And always look both ways before you cross the street. Sound advice, yes? Where does the vertical asymptote come from? Keep going. Good. Whatever makes the denominator 0 will generate a vertical asymptote. Okay. So, where's the vertical asymptote in f of x? Fine. Quit being bashful. Everybody, where's the vertical, or sorry, now you got me flustered. Where's the vertical asymptote in f of x? -1. Okay, good. Now, before we dive into this a little bit more, let's talk about graphing. So I know that I've got some function that has a vertical asymptote at -1. Now, you could cheat and get out your decimals. You could cheat and get out your calculator, but let's take a more theoretical, mature approach to this. We'll start on the right-hand side of the asymptote. What happens on the right-hand side of the asymptote? You should realize it's going to do one of two things. It's either going to do this, or it's going to do that. Which one?
It's going to go up.
Why? Or convince us.
If you plug in 1, which is past it, it gives you 1 over 4, which is positive.
Okay. So you're saying that because all the way over here at 1, the value is positive, then this must go up.
Yeah, and I bet if you plugged in...
What if it does this? I cut you off, though. You were going to say, and I would bet if...
If you kept in plugging in more points as it approaches the asymptote, it
Good.
would go up.
Good. So one of the big differences between calculus and, say, Algebra 1 is that a lot of times in Algebra 1, students think integrally. Integrally? They think in terms of integers. Okay, they neglect to consider the fractional aspects of this. So you might be saying to yourself, okay, well, I'm going to plug in 1 or 0, but we want to start talking about really, really close numbers. Like, for instance, -0.99999. We could even get a little bit simpler. What if you plug in -0.9? Okay. And I don't need a calculator to figure that out. If I plug in -0.9 there, will that stuff in the parentheses be positive or negative? Positive. Why? Is that a silly question? It should be, yeah, because I'm taking 1 and adding a -0.9. 0.9 is smaller than 1, so that would be positive. So now I get a positive over a positive, which is in fact positive, and Matthew, you're correct, it does that. Okay? What about on the left-hand side of that asymptote? Does it go up or down? Shane, why?
Because it'd be, the x would be slightly higher
Good.
than 1, which
Good.
means it would still be a negative,
Good.
which means if you multiply it by 2, it's still a negative,
Good.
which means if you divide that number by 1, it's still a negative.
Perfect. So the same logic we used on this side, use on the other side, and this would cause it to go like that. There's only two behaviors around asymptotes. They both head in the same direction, or they both head in opposite directions. That's going to become relevant for us when we start talking about limits. If we get rid of this business, the wrong answer over here, what's the limit at -1? Does not exist. Why?
These are going.
Get fancy with this. Use some calculus speak.
They have different. Like when x is approaching -1 from the left, the limit is -infinity. When it's approaching -1 from the right, it's +infinity. Therefore, the
Excellent.
limit does not exist.
Good. Well done. Where's the vertical asymptote on B? Say again? -1 and 1, correct. And we could go through that whole same argument again. Now we've got two asymptotes, 4 sides to test. Probably could find out a more efficient way to do that, which we will. Ooh. Had to throw some trig in there, didn't you, Reedy? Where are the asymptotes for cotangent? Matthew?
0 and 5.
Good. Remember, tangent is pi over 2, negative pi over 2. Cotangent is 0 and pi. Fancy way to say that, Matthew?
The asymptotes of cotangent x are 0 and 5.
And?
2 pi?
And?
It's the like weird k thing.
Yeah.
Where it's just like
I,
contains all.
I think we talked about this. Did you guys do K or N? You're N. Did you do K?
I don't remember.
I understand.
Okay.
Yeah, you just want to forget. It's like being in a traffic accident.
Yeah.
You just don't want to go back. You don't want to flash back to trig. I get it. Okay, so like we talked about, there's the -1 thing we looked at. As we approach a certain value, the function decreases without bound or increases without bound. And as it says, again, those are fancy terms for goes to infinity or goes to -infinity. They are, however, important. Remember the problem we went over last week with Eric about designing your own function based on the given information? One of the pieces of information they will say to you is f of x approaches or increases without bound as you get closer to x equals 4, whatever. You need to know what that means. It means it's going up to positive infinity as you get close to 4 from the left or from the right. This we talked about already. This is all just the fancy calculus speak for the things that we've talked about. Vertical asymptote comes from where the denominator is equal to 0, and then they throw in an f of x or g of x to give you that rational function. You have to have a denominator to get a vertical asymptote. We've covered this already. I jumped the gun. This one's a little bit different though because my denominator is squared. So we have an asymptote where, Alice?
At 1.
1. So if we go to the left of 1, if we go to the left of 1, so the limit as x approaches 1 from the negative direction of f of x. Is it positive infinity or negative infinity? Doesn't matter what happens in there, right? It's going to be positive. So this side's going to go like this. What about on the right-hand side? You pretty much answered the question.
Same
but-
thing.
Yeah.
Also positive.
Have you heard the term multiplicity before? No? Okay, it's an important term. I hope I can spell it. I can't even write an M. That's why I went into math. Multiplicity has to do with the behavior around asymptotes. So if I go back, I think I erased it. We'll use that one as an example. In that function, the multiplicity is defined as the exponent that the term that's generating the asymptote is raised to. I don't even know if that was English. This has a multiplicity of 1 because x minus 2 is raised to the first power. When your multiplicity is odd, it'll split along the asymptote. One goes up, one goes down. It can change on either side. If the multiplicity is even, then we get that puppy. They both go up or they both go down. It's an easy way to be able to recognize behavior around asymptotes without having to plug in numbers, test regions, do all that other fun stuff. And Atlas hit it on the head. Because that's an even power, it doesn't matter what I put inside, it's always going to be a positive value. So wouldn't they always go up? No, not necessarily, because if you stick a minus sign in there, it could cause them to flip. Okay, so again, odd multiplicity, they split. Even multiplicity, they both point in the same direction. Okay, so just for giggles, what's this? If I get rid of the minus, what's the limit as x approaches 1 of f of x? There are two possible answers. We talked about this already, but we'll go through it again. Emma?
Does not exist.
Good. Does not exist or positive infinity. And again, we talked about how math nerds would argue about infinity's not being a number, it's a concept. Therefore, the answer is does not exist. I don't care which one you use. For me, my brain processes infinity better than it does not exist, but that's, again, entirely up to you. We don't need to do a dead horse. I think we did that one already. Okay, good. All right, do that. Graph it on your grapher. Grapher is a fancy term for either your calculator or Desmos. Before you graph it, however, tell me where, Hafiz, tell me where the vertical asymptote is. -3. Is it going to do this, or is it going to do this? This. Why? There you go. Is the multiplicity even or odd? Odd. Very good. Okay. What else can you tell? Well, you're going to graph it. So then when you graph it, tell me what else you notice about the graph. Anything interesting other than the vertical asymptote? Mason? Are you asking me or telling me?
No, actually, I take that back.
You don't want to go with that?
No.
Okay. Are you sure?
I'm not sure.
Fine. We need to be neutral there.
I think it is.
Oh, you're arguing it is?
Yeah.
Why? Because you zoomed in?
Yeah,
Yeah.
I've been going for a while. It seems like it just won't touch.
Only 2 seconds.
What's a while for you? How far did you have to go out before you convinced yourself there was a horizontal asymptote?
Like
You
100.
over in like the thousands now?
Still over 2.
What's that?
It's still over 2.
Oh, interesting. Okay. Where is that vertical or that horizontal asymptote? Anybody? It's a precursor to what we're going to do on Thursday. How do you find?
Is it what makes the numerator 0?
No.
Is it?
That's something different, we'll get to that later.
Is that when whatever variables in front of the, or like what numbers in front of the variable and the numerator and denominator simplify?
Sometimes. So in this one, I will tell you, the horizontal asymptote is at 3. Because the numerator has a degree of 1 and the denominator has a degree of 1. We'll cover that later, I just wanted to see what you got. Okay, so we talked about the asymptotes already. All right, looking at your picture, write me a couple interesting limit questions. Like for instance, what is the limit as x approaches 10 of this function? Is that an interesting limit question? No, that would be silly. What do you got?
I have an error.
Oh boy, you broke it. You know what time it is? Time for your calculator.
Oh.
I'm kidding.
Oh, scared me a little bit.
Yeah, now you're good.
Thank you.
Yep. You got your plot thing you jot around.
Oh,
Are you taking stats too?
no. So I don't know why
I
that
don't know how that
happened.
got turned on then, yeah, but you're good.
Thank you.
Yep. Victor, what do you got for me? Limit question?
Sure. Yeah. It's just
We'll call this f of x. What would be an interesting number to approach for this function?
This approach is -3.
From the left, from the right, or at 3?
At 3.
At 3. What's the answer?
There's no answer.
Which one do you want to go with?
Does not exist.
Em, give me another one.
As x approaches -3 from the right,
Answer?
negative infinity.
I don't know what the graph looks like. From the right. Yeah, good, negative infinity. Hopefully you notice that any point that you approach other than -3 just becomes a plug and chug problem. What we're going to talk about on Thursday is we're going to change this to something like infinity. What happens as you go very far out to the right? If you keep scrolling on your Desmos, what will that function approach? Okay, but that's for later. It's also fairly easy. Okay? That's what we're going to talk about on Thursday. And we're done. Okay? Questions on any of that? A lot of that is kind of pre-calc review. There's not a lot of calculus going on there. You talked about vertical asymptotes in pre-calc, maybe even algebra 2, maybe even algebra 1. What we did talk about, though, is the theory of what happens around those asymptotes.